Welcome. Today, we're diving into the world of continuously variable transmissions, or CVTs, to answer a common question that many car buyers ask. This diagram shows how a CVT works, using pulleys and a belt to provide continuously variable gear ratios. But the question remains, are some manufacturers better at building these systems than others? The short answer is, it's complicated. There's no single manufacturer that makes the absolute best CVT for every situation. The best CVT depends on several key factors. Let's explore what really matters when comparing CVT transmissions. The best CVT depends on what you prioritize. Some excel in reliability and longevity, others focus on performance and responsiveness. Still others optimize for maximum fuel efficiency. The intended use also matters greatly. A CVT designed for a compact hybrid car has different requirements than one built for a larger SUV or performance vehicle. Throughout this series, we'll examine different manufacturers, explore the technology behind modern CVTs, and help you understand which systems might be best for your specific needs. To understand CVT transmissions, we first need to see how they differ from traditional transmissions. Traditional transmissions use fixed gears with specific ratios. CVTs work completely differently. Instead of fixed gears, they use a belt or chain connected to two variable diameter pulleys. This creates an infinitely adjustable transmission. The magic happens when the pulleys change their effective diameter. As one pulley gets smaller, the other gets larger, creating different gear ratios smoothly and continuously. Now let's look at a real CVT system. This diagram shows the actual belt and pulley mechanism used in modern CVT transmissions. The key advantage is that this system can maintain the engine at its most efficient RPM, regardless of vehicle speed. The transmission continuously adjusts to find the perfect ratio. This is fundamentally different from traditional transmissions, which force the engine RPM to jump between fixed points. CVTs provide infinite variability within their range. Think of a CVT as having an infinitely adjustable gear that's always in the right ratio. This continuous adjustment is what makes CVTs so efficient and smooth. CVT transmissions offer three significant advantages over traditional automatic transmissions. These benefits make them increasingly popular in modern vehicles. The first major benefit is improved fuel efficiency. CVTs can keep the engine operating in its optimal RPM range regardless of vehicle speed. This graph shows how fuel economy has improved over time, with CVTs contributing significantly to these gains. Unlike traditional transmissions that jump between fixed gear ratios, CVTs provide infinite variability. This allows the engine to stay in its sweet spot for maximum efficiency. The second benefit is the incredibly smooth driving experience. CVTs eliminate the jerky gear shifts of traditional transmissions. The belt and pulley system provides seamless power delivery. This smoothness is particularly noticeable in city driving conditions where traditional transmissions would constantly shift gears. CVTs provide a relaxed, comfortable driving experience. The third benefit is the simpler mechanical design. CVTs have significantly fewer moving parts compared to traditional automatic transmissions. This cutaway view shows the relatively simple CVT architecture. This simpler design can potentially lead to lower production costs and reduced manufacturing complexity. However, the specialized components and precise tolerances required still make CVTs sophisticated pieces of engineering. These three key benefits, improved fuel efficiency, smooth driving experience, and simpler mechanical design, make CVTs an attractive option for many modern vehicles, particularly in urban driving conditions. While CVTs offer many advantages, they also come with several notable drawbacks that drivers and engineers must consider. The most common complaint about CVTs is what's known as the rubber band effect. This refers to a noticeable lag or delayed response when you press the accelerator pedal. This happens because the CVT system takes time to adjust the pulley ratios to find the optimal gear ratio. Unlike traditional transmissions that have preset gear ratios ready to engage immediately. Early CVT designs also faced significant durability concerns. The belt and pulley system was prone to wear and failure, especially under high torque conditions or with inadequate maintenance. However, modern CVT designs have addressed many of these reliability issues through improved materials, better engineering, and more sophisticated control systems. The third major drawback is the driving experience itself. Many drivers find the lack of distinct gear shifts less engaging compared to traditional automatic or manual transmissions. Some drivers describe CVT operation as monotonous, with the engine maintaining a constant RPM during acceleration, rather than the rising and falling sounds associated with gear changes in traditional transmissions. Despite these drawbacks, manufacturers continue to refine CVT technology, addressing many of these concerns through improved designs and control algorithms. CVT adoption varies dramatically across different global markets. Understanding these regional differences reveals important insights about consumer preferences and automotive industry trends. Japan leads the world in CVT adoption, with these transmissions installed in approximately 68% of locally manufactured cars. This represents the highest penetration rate globally. China represents a significant and growing market for CVTs. Around 30% of car models in China now offer CVT options, reflecting the technology's increasing acceptance in this major automotive market. The United States shows lower CVT adoption rates, with approximately 22% of car models featuring CVTs. Traditional automatic transmissions with torque converters continue to dominate the American market. These adoption patterns reflect different market preferences and driving conditions. Let's examine what drives these regional differences in more detail. This comparison clearly shows Japan's leadership in CVT technology adoption. The high penetration rate reflects Japanese consumers' preference for fuel efficiency and smooth driving experience, particularly in urban environments. Several factors contribute to these regional differences. Urban driving conditions, fuel efficiency priorities, consumer acceptance of new technology, and regulatory environments all play important roles in CVT adoption rates. Despite lower adoption in some markets, CVT usage is growing globally as manufacturers continue to improve the technology and consumers become more aware of its benefits for fuel economy and driving comfort. CVT transmissions have found a perfect match in hybrid and electric vehicles. Their unique characteristics make them ideally suited for the instant torque delivery and varying power sources found in modern electrified powertrains. The key advantage lies in how electric motors deliver power compared to traditional internal combustion engines. Electric motors provide instant maximum torque from 0 RPM, while gasoline engines need to build up speed to reach peak torque. This instant torque characteristic of electric motors creates unique challenges for transmissions. Traditional automatic transmissions with fixed gear ratios struggle to efficiently manage this immediate power delivery. CVTs solve this challenge through their continuously variable gear ratios. Let's examine how the CVT's internal components handle the unique demands of electric and hybrid powertrains. The CVT's belt and pulley system can instantly adjust to optimize the power delivery from electric motors. Unlike fixed gears that create power interruptions during shifts, the CVT provides seamless power transfer. This smooth power transfer is crucial for hybrid vehicles that constantly switch between electric motor power, gasoline engine power, or a combination of both sources. The efficiency benefits become even more apparent when we examine the power characteristics across different operating conditions. Modern hybrid CVTs are designed to optimize performance across varying voltage levels and power demands. This power curve data shows how hybrid systems must manage varying voltage levels and power outputs. CVTs excel in this environment because they can continuously adjust to maintain optimal efficiency regardless of the power source or operating conditions. Recognizing these advantages, major manufacturers are now designing CVTs specifically for hybrid applications. These specialized transmissions incorporate unique features to maximize the benefits of electric motor integration. Honda and Toyota have developed hybrid-specific CVT control algorithms that optimize the interaction between electric motors and gasoline engines. These systems can seamlessly blend power sources while maintaining peak efficiency. Nissan has focused on dual power source management, creating CVTs that can efficiently handle the complex power flows in their hybrid vehicles while integrating regenerative braking systems for maximum energy recovery. The result is a transmission system perfectly matched to the characteristics of hybrid and electric vehicles, providing instant response, maximum efficiency, and the smooth operation that enhances the electric driving experience. CVT technology has undergone significant evolution in recent years. Modern CVTs incorporate several key technological advancements that address traditional limitations and improve overall performance. One of the most important improvements is the development of low-viscosity transmission fluids. These advanced oils reduce internal friction and improve power transfer efficiency throughout the CVT system. Advanced materials and engineering have led to low-friction belts and pulleys. These components use specialized coatings and precision manufacturing to minimize energy loss during power transmission. Unit body construction represents a major engineering breakthrough. By integrating components into a single, unified structure, manufacturers have reduced the number of parts and improved control precision, significantly reducing the rubber band effect. Perhaps the most innovative advancement is the introduction of launch gears. This technology, pioneered by manufacturers like Honda and Toyota, adds a dedicated gear for low-speed operation, dramatically improving responsiveness and efficiency during acceleration. These technological advancements work together to create modern CVTs that are more efficient, responsive, and reliable than ever before. The combination of advanced materials, precision engineering, and innovative design solutions has transformed CVT technology into a competitive transmission option. Modern CVT transmissions are becoming increasingly intelligent through the integration of artificial intelligence and sophisticated control systems. At the heart of modern CVTs is an AI-powered control system that continuously processes data from multiple sensors throughout the vehicle. The AI system receives real-time data from engine RPM sensors, vehicle speed monitors, throttle position sensors, road condition detectors, and driver behavior analyzers. This data flows into the CVT control unit, which uses machine learning algorithms to optimize the transmission's behavior in real time. The AI system continuously adapts to changing driving conditions. When it detects aggressive acceleration, it adjusts the CVT ratio for maximum power delivery. During highway cruising, the AI prioritizes fuel efficiency by keeping the engine in its most efficient RPM range. In stop-and-go traffic, the AI learns the driver's preferences and adjusts the transmission response for smoother, more comfortable operation. Modern AI-integrated CVTs feature sophisticated monitoring systems that provide real-time feedback and continuously optimize performance parameters. This AI integration represents a significant advancement in transmission technology, making CVTs more responsive, efficient, and tailored to individual driving styles than ever before. Nissan stands as one of the automotive industry's early pioneers in CVT technology. The company recognized the potential of continuously variable transmissions long before many competitors, making significant investments in this technology. Nissan's early adoption of CVT technology positioned them as innovators in transmission design. Their commitment to this technology was evident in multiple vehicle models throughout their lineup. However, Nissan's early CVT models faced significant reliability challenges. Many owners experienced premature transmission failures, overheating issues, and costly repairs that damaged the brand's reputation in this technology area. Nissan responded to these challenges by developing the X-Tronic CVT, incorporating lessons learned from earlier problems. This newer generation features enhanced durability, better heat management, and improved software control systems. When considering a used Nissan with a CVT, thorough research is essential. Check the specific model year's reliability ratings, verify maintenance history, and consider models from 2013 onwards, which generally show improved reliability compared to earlier versions. While Nissan continues to refine their CVT technology and address past issues, the company's early challenges serve as an important reminder that not all CVT implementations are equal. Due diligence and research remains crucial for potential buyers. Honda and Toyota have established themselves as the undisputed leaders in CVT technology. These two Japanese manufacturers have consistently delivered the most reliable and efficient continuously variable transmissions in the automotive industry. Honda has been perfecting CVT technology since 1996. Their transmissions are renowned for exceptional reliability, featuring advanced unit body construction that reduces the rubber band effect and provides smooth, responsive acceleration. Honda's CVT design features precision-engineered internal components that work together seamlessly. This exploded view shows the sophisticated engineering that makes Honda CVTs so dependable. Toyota leads the industry in hybrid CVT integration and has pioneered launch gear technology. Their CVTs feature AI-powered adaptive control systems that optimize performance based on driving conditions, delivering exceptional fuel efficiency. Both manufacturers excel in different areas, making them the top choices for CVT technology worldwide. Honda and Toyota lead in 4 critical areas: reliability with transmissions lasting over 200,000 miles, efficiency through optimal engine RPM control, seamless hybrid integration, and advanced AI technology that eliminates the traditional rubber band effect. Industry experts consistently rank Honda and Toyota CVTs as the most reliable on the market. Their commitment to quality engineering and continuous innovation has made them the benchmark for CVT technology worldwide. Subaru has developed their own unique approach to CVT technology with the lineartronic transmission. This system is specifically engineered to work seamlessly with Subaru's signature all-wheel drive architecture. The lineartronic CVT uses advanced pulley and belt technology to provide smooth, continuous gear ratios. Unlike traditional CVTs, Subaru's design incorporates specific enhancements for durability and performance. Subaru's lineartronic CVT features several key improvements, including a chain-driven design for enhanced durability, improved responsiveness compared to earlier CVT designs, and specific optimization for all-wheel drive applications. The most distinctive aspect of Subaru's approach is how the lineartronic CVT integrates with their symmetrical all-wheel drive system. This creates a unique drivetrain architecture. This diagram shows Subaru's symmetrical all-wheel drive system. The lineartronic CVT is positioned to send power efficiently to both front and rear axles, creating optimal weight distribution and traction control. Over recent years, Subaru has made significant improvements to the lineartronic CVT's reliability and performance, addressing earlier concerns and enhancing the overall driving experience. This timeline shows the evolution of Subaru's lineartronic CVT. From its initial launch in 2010 through enhanced durability improvements in 2015, improved responsiveness in 2020, and advanced control systems in 2024. Today's lineartronic CVT offers proven reliability in all-wheel drive applications, optimization for Subaru's unique boxer engine layout, enhanced fuel efficiency and performance, and improved maintenance intervals compared to earlier versions. Subaru's lineartronic CVT represents a successful integration of CVT technology with all-wheel drive systems, demonstrating how manufacturers can adapt CVT designs to work with their specific vehicle architectures and performance requirements. Jacko stands as one of the world's most significant suppliers of continuously variable transmissions. Unlike automakers who build complete vehicles, Jacko specializes in designing and manufacturing advanced CVT systems for multiple car manufacturers globally. Jacko was established as a joint venture and has grown to become a cornerstone of the CVT industry. The company supplies transmissions to major automakers and has built a reputation for advanced engineering and innovative designs. This cutaway model demonstrates the sophisticated engineering that Jacko brings to CVT design. The yellow highlighted sections reveal the intricate internal components that make their transmissions highly efficient and reliable. Jacko holds a commanding position in the global CVT market with over 15% market share. They supply transmissions to major brands including Nissan and Infiniti, and are particularly known for their Xtronic CVT technology, which represents continuous innovation in transmission design. This technical diagram showcases the complexity of modern CVT systems that Jacko engineers. Multiple sensors and precisely engineered components work together to deliver smooth, efficient power transmission across a continuous range of gear ratios. Jacko's advanced CVT technologies include low-friction belt and pulley systems that maximize efficiency, sophisticated control algorithms that optimize performance, enhanced durability components for longer service life, and specialized designs optimized for hybrid vehicle applications. The CVT-7 represents Jacko's latest generation of transmission technology. This detailed view shows the precision engineering and advanced materials that make Jacko a trusted supplier to automakers seeking reliable, efficient CVT solutions. Jacko's role as a major CVT supplier has significant industry impact. By enabling automakers to offer efficient CVT options without developing their own transmission technology, Jacko drives innovation across the automotive industry and supports global fuel efficiency goals through their advanced engineering solutions. We'll examine a real-world case study involving a 2012 Nissan Murano that demonstrates the importance of proper CVT diagnosis and targeted repairs. This 2012 Nissan Murano came to the shop with a complete loss of power transmission. The initial diagnosis suggested a full CVT replacement, which would have been extremely expensive for the customer. However, a more detailed diagnosis revealed that the problem was not with the entire CVT system, but with a specific component, the pump flow control valve. This small valve was causing low hydraulic pressure, preventing proper operation. The solution was a targeted repair using a superior transmission parts flow control valve. This involved removing the original faulty valve and spring and replacing them with an improved design that restored proper hydraulic pressure. The cost difference was dramatic. While a full CVT replacement would have cost between $4,000 and $6,000 plus labor, the targeted valve repair cost only $200 to $400, representing a savings of over 90%. This case study teaches us several important lessons. Proper diagnosis is crucial before assuming the worst. Targeted repairs can save thousands of dollars. We shouldn't rush to replace entire systems when a specific component may be the culprit. And it's essential to seek experienced CVT technicians who understand these complex systems. The Nissan Murano case demonstrates that with proper diagnosis and the right expertise, what initially appears to be a catastrophic transmission failure can often be resolved with a simple, cost-effective repair. The global CVT transmission market reached a substantial size in 2024, valued at $9.8 billion. This represents the total worldwide market for continuously variable transmissions across all automotive manufacturers. Within this large market, two companies stand out as the dominant players in CVT technology and manufacturing. Jacko and Toyota together hold a commanding position in the CVT market, with each company controlling over 15.5% market share. This means these two companies combined control over 31% of the entire global CVT industry. Jacko operates as a major CVT supplier, providing transmissions to multiple automotive manufacturers worldwide. Their expertise in CVT technology has made them a key player in the industry. Toyota has established itself as a technology leader in CVT development, particularly excelling in hybrid vehicle applications. Their continuous innovation has secured their position as a market leader. Together, these two industry leaders demonstrate the concentrated nature of CVT expertise, controlling nearly one-third of the global market and setting the standards for CVT technology advancement. The CVT transmission market is experiencing significant momentum, with strong growth projections extending through the next decade. Industry analysts project the global CVT market will grow at a compound annual growth rate of 6.4% from 2025 through 2034. This growth trajectory spans nearly a decade, representing sustained expansion in the automotive transmission sector. Two primary factors are driving this robust growth. First, the increasing global demand for fuel-efficient vehicles as consumers and governments prioritize environmental sustainability. Second, rapid automotive market expansion in developing countries, where CVT technology is gaining significant traction among manufacturers and consumers. Fuel efficiency remains a critical consideration for consumers worldwide. Comparative studies demonstrate the importance of transmission technology in optimizing fuel consumption across different engine types and operating conditions. Regional automotive sales data reveals significant opportunities in developing markets. Countries in Asia-Pacific, South America, and other emerging economies represent the fastest-growing segments for CVT technology adoption. This sustained growth projection reflects the automotive industry's continued evolution toward more efficient transmission technologies, positioning CVTs as a key component in the future of vehicle powertrains. CVT reliability has dramatically improved over the years. While early CVT transmissions had durability concerns, modern CVTs tell a completely different story. The journey from early CVT technology to today's advanced systems shows remarkable progress. Early CVTs from the 1990s and 2000s faced significant durability challenges. However, modern CVTs, developed from 2010 onwards, can reliably last over 200,000 miles when properly maintained. This represents a complete transformation in CVT technology. Let's examine what makes modern CVTs so much more reliable and how proper maintenance ensures maximum longevity. Modern CVTs can achieve impressive longevity. With proper maintenance, these transmissions can reliably operate for over 200,000 miles. The key to achieving this longevity lies in understanding that CVTs have precision-engineered components that require specific maintenance to function optimally. The most critical factor in CVT longevity is regular fluid maintenance. CVT fluid is the lifeblood of these transmissions. Regular CVT fluid changes every 50,000 miles or less are absolutely crucial. This maintenance schedule is the foundation of CVT longevity. This regular maintenance schedule is not optional, it's essential. Fresh CVT fluid ensures proper lubrication, cooling, and hydraulic pressure for all internal components. Real-world maintenance records demonstrate the importance of following these service intervals. Professional service documentation shows exactly what proper CVT care looks like. This actual service invoice shows proper CVT maintenance in action. Notice the specific CVT fluid type and the professional diagnostic procedures that ensure optimal transmission health. Modern CVTs have proven their reliability when properly maintained. The combination of advanced engineering and regular fluid changes every 50,000 miles creates transmissions that can reliably serve drivers for over 200,000 miles. Automotive experts have specific recommendations when it comes to purchasing used Nissan vehicles equipped with CVT transmissions. Understanding these expert insights can help you make an informed decision and avoid potential costly repairs. Many automotive experts recommend exercising caution when considering used Nissan vehicles with CVT transmissions. This recommendation is particularly strong for older models manufactured between 2007 and 2014, which experienced higher rates of transmission problems. This timeline shows the risk assessment for different Nissan CVT model years. The highest risk period was from 2007 to 2013, when Nissan was still refining their CVT technology. Models from 2016 onward show significant improvements in reliability. A thorough pre-purchase inspection is crucial when considering any used Nissan with a CVT. This inspection checklist shows the key areas that should be evaluated, including CVT fluid condition, transmission operation, and complete maintenance records. Having a qualified mechanic perform the inspection is essential because CVT transmissions require specialized knowledge to properly evaluate. A professional can detect problems that might not be apparent during a simple test drive and can provide accurate repair cost estimates. When inspecting a used Nissan CVT, specific components require careful attention. The belt or chain condition is critical, as replacement can be extremely expensive. The pulley system should operate smoothly without scoring, and the hydraulic system must maintain proper pressure for reliable operation. The expert consensus is clear. While newer Nissan CVTs have improved significantly, extra caution is warranted with pre-2015 models. Always invest in a professional inspection and thoroughly review maintenance records before making a purchase decision. This small upfront cost can save thousands in potential repair bills. CVT transmissions present unique challenges when it comes to repair costs. Unlike traditional automatic transmissions, CVTs require specialized knowledge and parts that can make repairs significantly more expensive. CVTs contain highly specialized components, including variable pulleys, steel belts or chains, and sophisticated hydraulic control systems. Each of these parts requires specific expertise to diagnose and repair properly. When CVT components fail, such as this heat-damaged belt link, the repair process becomes complex and costly. Several factors contribute to higher repair expenses compared to traditional transmissions. This cost analysis demonstrates a real-world scenario where replacement may be more economical than repair. When repair costs approach 60 to 70% of replacement cost, many experts recommend full transmission replacement. The decision between repair and replacement depends on several key factors. Vehicle age, mileage, extent of damage, and cost ratios all play important roles in making the most economical choice. The specialized nature of CVT technology means that repair costs can quickly approach replacement costs. Professional diagnosis and cost analysis are essential for making informed decisions about CVT maintenance and repair. CVT transmissions are positioned to play a crucial role in the automotive future, particularly as vehicles become electrified and autonomous. Their unique characteristics make them ideal for next-generation vehicle technologies. Electric motors produce instant torque and operate efficiently across a wide speed range. CVTs are perfectly suited to handle these characteristics, providing smooth torque management and maintaining optimal efficiency throughout the entire operating range. Modern CVT designs are being specifically optimized for electric and hybrid powertrains. The belt and pulley system can efficiently transfer the instant torque from electric motors while maintaining the smooth, stepless operation that enhances the electric driving experience. As we move toward autonomous vehicles, CVT transmissions will need to become even more sophisticated to meet the complex demands of self-driving technology. Autonomous vehicles require transmissions that can respond instantly to artificial intelligence decisions. The vehicle's control systems must coordinate with the transmission to provide precise speed and torque control for safety-critical maneuvers. Future CVTs will need sophisticated integration with artificial intelligence systems, predictive algorithms that anticipate driving needs, enhanced fault tolerance for safety, and real-time optimization to maximize efficiency and performance in autonomous driving scenarios. CVT technology is evolving to meet these future challenges. Their inherent efficiency, smooth operation, and adaptability make them well-positioned to serve as the transmission of choice for the next generation of electrified and autonomous vehicles. Regardless of the manufacturer, regular maintenance is absolutely essential for maximizing the lifespan of any CVT transmission. The most critical maintenance task is regular fluid changes. CVT fluid is specially formulated and different from regular transmission fluid. The image shows a proper CVT fluid change setup with the correct fluid bottles, funnel, and tools needed for the job. The process requires using manufacturer-specified fluid, following proper procedures, and checking fluid condition regularly. Most experts recommend changing CVT fluid every 50,000 miles or less. Choosing the correct fluid type is crucial. This Subaru application guide shows how different models and years require specific CVT fluids. Each manufacturer has their own formulations. Different CVT systems require specific fluids, and using the wrong fluid can cause serious damage. Always consult manufacturer specifications before performing any fluid change. Following manufacturer maintenance schedules is essential. This Honda preventive maintenance schedule shows how regular service intervals help prevent costly problems before they occur. Preventive maintenance saves money in the long run. Scheduled intervals prevent problems, professional service is recommended, and documenting all maintenance helps track your vehicle's service history. The difference between proper maintenance and neglect is dramatic. Vehicles with regular CVT fluid changes can last over 200,000 miles with smooth operation and lower repair costs. In contrast, neglected CVT maintenance leads to premature failure, expensive repairs, poor performance, and often requires complete transmission replacement. Regular fluid changes are the key to CVT longevity. After examining all aspects of CVT technology, manufacturers, and market trends, we can now draw some important conclusions about choosing a vehicle with a CVT transmission. Our analysis reveals that there is no single best CVT manufacturer. The optimal choice depends on your specific needs, vehicle type, and intended use. However, Honda and Toyota have consistently established strong reputations for CVT reliability and performance, particularly in hybrid vehicle applications. When choosing a vehicle with a CVT, thorough research is essential. You should investigate the specific model's reliability ratings, the manufacturer's CVT track record, and how well the transmission suits your driving needs. CVTs offer excellent fuel efficiency and smooth driving experiences, particularly in hybrid applications. Honda and Toyota models are generally recommended for their proven reliability, but always research the specific model and prioritize proper maintenance. Thank you for watching this comprehensive guide to CVT transmissions. We hope this information helps you make an informed decision when choosing your next vehicle with a CVT.